In this video, we're going to take a look at some higher powered factoring techniques. And as necessary, you are welcome to pause the video or rewind and view other examples as we go along. You'll notice that most of the techniques that you see here are just going to be variations of ones that we have already demonstrated in class. So here we go. Okay. This first example, we have 3x cubed minus 15x squared. This one is just purely review because I want to remind you that we should always factor out the greatest common factor first. And that makes it very easy to factor the problem. Okay, I could take a 3 out of both of those and also take out an x squared, since that is the smallest power that both of them have. Okay. In this next example, I have y squared minus 49. As noted before, you could take the square root of both of those, and because it is subtraction, that makes it the difference of two squares. And because it is the difference of two squares, we have a technique for factoring this that goes pretty quickly for us, because it is simply square root of the first minus the square root of the second, and square root of the first plus the square root of the second. And that works all the time. In this one, we have to use a different technique because we have four terms. The first technique that I would try is to factor by grouping. So I'm going to try to group the first two terms, then I'm going to group the last two terms and try to factor out things from there. So all I've done is I've added parentheses around the first two terms and around the second two terms. Now I look at each group and try to determine, is there something that I can factor from each one? In the first group, I can take out an x. In the second group, I can take out a 3. And what that does is that leaves me with y plus 5 in parentheses in both terms. That's something else that I can factor out. Okay, I can factor out a y plus 5, and then what I'm left with is an x plus 3. I notice that the numbering does go from 2 to 4, but it's because I skipped an example. So I caught that. Okay. On this next sheet, we have another example here. 4m squared plus 4m plus 1. Now, this one does work out nicely, but if you have already seen the pattern, you can go ahead and factor it in one step. But just in case, just a reminder, you can multiply the first and last terms together and then split that up to create the middle term. So I rewrote the 4m as 2m plus 2m, and then I'm going to factor the rest by grouping. Okay, so I'm going to take a 2m from the first group, and the second group, there's nothing I can take out, but I can always take out a 1. So since I can take out a 2m plus 1 from each of those terms, I'm left with 2m plus 1 times 2m plus 1, but ultimately that means I can write that as 2m plus 1 squared if I wanted to. Okay. This next example, it only has two terms, but whenever I see this, the first instinct I should have is to try to take the square root of each one. And as you can tell, you can take the square root of 16 and the square root of 1, and the square root of x to the fourth is x squared. You simply half the exponent. So I already know from before that I can take the square root of the first minus the square root of the second, and square root of the first plus the square root of the second. But if you notice, you have difference of two squares yet again. So you could factor this one down as well. So that's why I have 2x plus 1 and 2x minus 1 from this first group here. You cannot factor the 4x squared plus 1. The sum of two squares does not factor using integers and real numbers. Okay. In the next example, I have multiple variables. This may not be the first time you've seen those, so it may not be that much of a conundrum for you. However, we're going to do it the exact same way. Okay, I'm not going to be concerned about the different variables because if you notice, the middle variables have half the exponent of their outside variables. So that means that I'm going to be able to factor this using a traditional technique. So I'm going to take the 4 and the 9 and multiply them together, and that's going to give me 36. So I need numbers that multiply together to give me positive 36, but add together to give me negative 12. So negative 6 and negative 6 do the trick. And I split my expression up accordingly. Now notice that these exponents did not change, they just got split up amongst them. So now I'm going to factor using groups again. Okay? Or you may use the technique of your choice. Okay? So I put parentheses around the first two, parentheses around the second two, being sure to include this sign. That's imperative. So now when I factor out the GCF from each group, the first group, I'm going to factor out a 2m to the fourth. And in the second group, because that 6 is negative, I'm going to factor out a negative 3, because 3 goes into both 6 and 9. And they both have p's. And the smallest power of p is 3. So I'm going to factor out a negative 3p. So in my parentheses, I have 2m to the fourth minus 3p cubed. Over here, I took out a 3p cubed. And inside parentheses, I have 2m to the fourth minus 3p cubed. So I can rewrite that now. And the groups are the same, allowing me to rewrite it as 2m to the fourth minus 3p cubed squared. Okay. The next example brings us to something that's a little bit simpler. Okay. But again, it has two variables, so some people may feel uncomfortable. However, I'm just going to ignore the fact that I have two different variables and remember my simple factoring techniques. Numbers that multiply to 12 that give me 7 are 3 and 4. And the fact that I have r's in front and s's in back means that both of my parentheses are going to have r and s. Okay. So I just substitute the numbers in as such. The multiple variables do not concern me. I just factor it the way we normally would. Okay. This next example, this one simply has a number in front of n squared, and I wanted to take a moment to review that as well before we get into anything more difficult. So again, I multiply the 2 and the negative 18. That gives me negative 36. And numbers that multiply together to give me negative 36, but add together to give me positive 9 are 12 and negative 3. So I split that middle term up as such. Then I place parentheses around the first two terms and the last two terms, being sure to include that sign again. So in the first group, I could take out a 2n. In the last group, I could take out negative 3. So the checkpoint here is these parentheses are the same, so I know I'm right. So I have 2n minus 3 in one group and n plus 6 in another. And that problem is finished. This next one looks a little odd, but having seen something similar to it last unit, you may already know where I'm going with this. If I'm going to factor this, we're not used to factoring x to the 2n, when then x to the n in the middle. Well, if you remember our rules, okay, that is x squared n minus 2x to the n plus 1. So I'm going to use a substitution. I'm going to say x to the n is g. So that means that this is going to become, since I have x to the 2n power, this is just going to become g squared. Regular x to the n is just going to be g. I'm going to have plus 1. So now I have something easy I can factor. So I factor it down. I get g minus 1 and g minus 1. But remember, you have to substitute back in. So you get x to the n minus 1 times x to the n minus 1. And you can even write that as x to the n minus 1 squared if you wish. So this brings us to the next step in our journey. It's time to start thinking about solving. And when we solve, we have to use the zero product property because we need to set our expression equal to 0. The reason why this works is because of the zero product property. It says when you have two things multiplied together, one of those two things must be 0, but you don't know which one. So that's why it works. So you've already used this this year, so I'm not going to dwell too much on some of the basic points. So I have an expression here. You want to make sure to keep the r squared term, keep the squared term positive. It does make factoring much, much simpler. Okay? So now 3 times negative 8 is negative 24, and negative 24 can be broken down into, can be multiplied also by 2 and negative 12, but those also add together to give us negative 10, which is what we want. Now I'm going to do the same thing. I'm going to factor out a GCF from each of these after putting them in parentheses. But now that it's equal to 0, I need to set each group equal to 0. Now, I don't know which answer it is, but I do know that after setting them equal to 0 and I solve each one, I get 2 answers. I don't know which one it is. It doesn't matter. Whatever r happens to be, I know it's one of those 2 numbers. Okay. So here's one that's a little different. Okay. Again, this is just something that you need to simplify. Okay. I would not take the square root of both sides because that's going to put a variable in the radical. That's not going to be helpful. So why don't we just multiply this out? We know that when you square a binomial, you square the first term, multiply the 2 terms together and double it, and square the last term. So that's exactly what I did here. And then I moved this c to the other side. So numbers that multiply together to give me 36, but add together to give me negative 13. That would be negative 4 and negative 9. So set each group equal to 0. And there you go. Now, it is definitely helpful to plug these numbers in and make sure that they both work. In this case, I know for a fact they both do. But it never hurts to check. Now, since you've been doing that, plenty with the solving, I wanted to take a moment and do some more factoring. Some perhaps ones that you might consider a little uglier. So here's one for you. I have PQ minus 2Q plus 2P minus 4. Well, factor by grouping. Put parentheses around the first 2, put parentheses around the second 2, and go from there. Now I could take out a Q from the first group. I could take out a 2 from the second group. And I have groups that are the same, so I get Q plus 2 on the outside. So that's my second group. I have Q plus 2 and P minus 2. I cannot solve this because I do not have an equals sign up here. And plus I have 2 separate variables, so I can't solve this. But it is factored. Okay. The next one. Okay. Again, I'm back to the 2 variables. And since there are 4 terms, I'm going to try to factor by grouping. So looking at this, it's not in perfect form to do that though. Because if you notice, I have AB, I have no variable, I have B, and then I have A.